Good morning all. Myself Arul Soumya, working as an assistant professor in Department of Computer Science and Engineering. So here I'm going to discuss a topic on data sources. Here we are going to see a subtopic which is on introducing naive Bayes classifiers. So what is naive Bayes? So here a probability based machine learning algorithm. So neighbors in the sense it is a probability based machine learning algorithm and it is based on a Bayes theorem and it assumes features are independent. So that's why it is called naive. That is here the features of data, every data's results are independent. So mainly it is used for classification problems. So for example, email spam, we can identify whether the email is spam or not spam. So we can get easily identify the process here. So naive Bayes theorem. So coming to Bayes theorem, here there are three probabilities, which is first one is conditional probability, second one is joint probability, and third one is marginal probability. So in condition probability, the probability of label Y that is occurring as a result of the given feature X. So in joint probability, the probability of features X occurring together with label Y. So in marginal probability, the probability of feature X occurring in a probability of possible labels Y. So these are all the Bayes theorem formula. So Bayes in the formula in the sense the probability of y slash x is equal to probability of x and y divided by probability of x. So let's see working of naive Bayes. So naive Bayes classifier process. So there is 5 steps here. The first one is data collection. The second one is feature extraction. The third one is probability calculation. The fourth one is Bayes theorem application. And then fifth one is classification. So in data collection, we can gather and organize the data set from a data center. So in feature extraction, we can identify the relevant features from the given data. And in probability calculation, we can compute the probabilities for each feature. And in Bayes theorem application, we can apply Bayes theorem to calculate posterior probabilities. And finally, in classification, we can assign the data point to the most probable classifications. So let's come to see an application of naive Bayes theorem. So here it shows the applications using naive Bayes algorithm. The first, we can get a text classification and then we can get a sentiment analysis. And next one is recommendation system. And then we can filtering this from that is spam filtering. And then in medical diagnosis and then weather prediction and we can get face recognition. So these are the parts we can get the applications using by naive Bayes algorithm. So let's see pros and cons of naive Bayes. So what are all the advantages and limitations here? So here the main advantages, it is easy to implement and it requires less training data and it is very fast compared to other algorithm and it works well with text data. So limitation in the sense it assumes independence, that is not always realistic. So the main pros in this naive algorithm is it is easy to implement and it requires less training data and is very fast to process and then it works with text data. So conclusion. So coming to the conclusions in naive Bayes, we can get naive Bayes is a simple and efficient probabilistic classifier and it is based on Bayes theorem and conditional probability. So here it performs well even with large data sets in a data centers. So especially it is effective for text and document classification. So here we can get either the text and document in either in a table or a row format and or in a graph format. And finally, it requires less training time compared to other algorithms. So compared to other algorithm, the naive Bayes algorithm requires a less training time. So that's all about naive Bayes classifier. Thank you.